Okay, young people, we're going to talk a little bit about scientific notation here and talk a little bit about the reasons why. So if you look at this chart, we have lots of numbers that are in scientific notation. For example, 5.98 times 10 to the 24th kilograms. That's the mass of the Earth. That's a really, really, really big number. Then if we look at the bottom and we see 1.67 times 10 to the negative 27th kilograms, that's a really, really small number. That is the mass of a neutron in kilograms. So we deal with really large and really small numbers, and we have to make sure that we understand what those are. So in science, we deal with a large number like this one. 602-000-000-000-000-000-000. So lots of zeros to be saying over and over and over again. Lots of zeros to be typing into a calculator each and every time you want to use this number to calculate. And we also deal with some very small numbers. For example, this is the mass of an electron in kilograms. And I'm not going to bore you by repeating all of those zeros that are right there. You just know that there are quite a few of them. So imagine the difficulty if you were trying to calculate the mass of 1 mole of electrons. So basically, we'd have to take the mass in kilograms, that very, very small number, and multiply it by that very, very large number. And each time we had to do this, we would have to press in every single one of those zeros exactly the same way to get the same answer every single time. And I don't know about you, but that would be quite hard to do, okay? Quite hard to do to repeat every single time. So we're going to use something called scientific notation. And scientific notation is very important because it's going to represent these really large and really small numbers. Now, there are a couple things that we need to make sure that we're aware of. The first thing that we need to make sure that we're aware of is that we are doing two things. The first thing that we need to make sure that we do is it's the same number. Means the same amount. So we have to ensure that the number means the same amount. We also have to make sure that we keep the same significance. The same significance. That means that the tool that it was measured on still has to represent the same tool. So whatever numbers were certain and whatever numbers were not certain, we still have to make sure that we show that. So the way that we do that is we take a number that is very large or very small, and we change it into this format where we have a number m and times 10 to the n, okay? And so if n is a positive number, then basically what we're saying is we're saying 10 times 10 times 10 times 10 n times, okay? If n is a negative number, we're saying divide by 10, divide by 10, divide by 10 n times. But dividing by 10 also means that we're multiplying by 1 over 10. These two things are the same thing, 1 over 10, 1 over 10. And so what this does is this is for the really small numbers, and this one is for the really large numbers. Sorry, I'm not writing very well. The really large numbers. So that's the n portion, and that's what it literally is meaning. The m portion has to be a number between 1 and 9.99. That means you can't have more than one digit to the left of the decimal point. You can't have less than one digit to the left of the decimal point either. So you have to have one digit to the left of the decimal point. That's the requirement. So if we look at this number, we can see that there is no decimal point mentioned here, but we know where the decimal point is in this number. We know where to assume it is. So let's see if we can assume that. So we have to insert the understood decimal point. And there we go. We inserted the understood decimal point. There it is in purple. Okay. Step 2 is we have to decide where the decimal must end up so that there is one digit to the left of the decimal point. So we have to decide where that's going to happen. So where are we going to put that? We follow the arrow and we see, oh, we're going to put it between the 2 and the 5. So the 2 is the only digit that's going to be to the left of the decimal point. And that's okay because there's only one digit to the left. Next, we have to count the number of places that we have to bounce where the decimal point is to where we need it to go. So we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9 places. And we're going 9 places to the left. Now we have to rewrite it in the correct form. M times 10 to the nth. Okay, where n is equal to the number of places we bounce the decimal, and m is the new number with the right number of significant figures. So our answer would be 2.5 times 10 to the 9th. Okay, so the exponent is the number of places we move the decimal, and literally what that means is we've taken 2.5 times 10, 1, 2, 3 tens, 4 tens, 5 tens, 6 tens, 7 tens, 8 tens, 9 tens. That's literally what that problem is saying. So this means what I've written right there. And that's what it's talking about. So here's another example, but this time this number is small. So we're going in the opposite direction. That means that the n part is going to get smaller. The n part got bigger when I was moving left. When I go to move right, it's going to get smaller. But I still have to follow the same rules. So I already have where the decimal is. Now we need to decide where the decimal point should end up. So it should end up with 1 digit to the left. So that's going to be ending between the 5 and the 7. Then we have to count how many places we bounce the decimal point. We go 1, 2, 3, 4, 5 places. And remember, we went right. So it's not 5 tens, it's actually something different. So now we have to rewrite it in the form what we have here. So here's the answer. 5.79 times 10 to the negative 5th. It's smaller because the number was smaller. And literally, remember, the exponent is negative because the number we started with was less than 1. So literally what this means is 5.79 times 1 over 10 times 1 over 10 times 1 over 10 times 1 over 10 times 1 over 10. That's what it means when we see the negative. We're dividing by 10 every single time. Okay, so that's where we're going to end here, and I'm going to have you watch another video because he's going to do a lot more examples for you and give you some ideas of how to do that. So make sure that you're thinking about that as you're moving through there.